So for those of you that were not in class today, here's the first bit, and then this flip chart is online. What I did was go through each question of the test and give a little hint on how to fix most of the questions. So if you don't want to print it out, you can press pause on each of these pages. So I'll go back once more. And then here's the last page. Please register for your AP exams. Let's see. All right. So this was, I think, the second free response. I think I have them on the board backwards. This was the water question, water tank. So just starting off, they gave you two functions. Let's see. This is their way of giving you an initial value. And then the other thing you should notice, there's endpoints. So if they ask me for absolute max or mins, I know I'm going to have to check them. So I picked this problem because the questions are pretty similar to things you've done. The difference is they're giving you two functions instead of one. So it's trying to figure out how do those two functions relate. So is the amount of water in the tank increasing or decreasing or increasing at the time 15? So if I just knew the rate at which the water is changing, then I would know if it's increasing or decreasing, right? If I knew the derivative. So they're giving you two different rates. So I'm going to use G as my gallons of water. The gallons of water, if I knew its derivative, then I would be able to answer part A. And the derivative was the rate of the water going in minus the rate of the water going out. So that actually is the derivative function that they're giving you. Just a little bit tricky. So that started you off here. Are we clear on that? At that point, you're using a calculator. You put the two functions in, subtract them, substitute in 15, figure out if it's positive, negative, or 0, right? We're good there? All right. How many gallons are in the tank? So now they want me to know how many gallons are in the tank at time equal to 18. Then that would be an initial plus a displacement. How do I know that? Because they gave me the rate at which the water is changing. They never gave me the actual function, so I would have to take an integral. So if I have a rate, but I want the original function, then I need an integral. Integral means I'm going to need an initial value. So that was g of 0, which is what I'm calling this function g, plus the displacement, which would be from 0 to 18 of g prime, but I'm going to use what they have. Are there any questions on part B? Part C, absolute minimum. So this is where it gets a little bit more difficult. So part C asked me for an absolute minimum. I'm trying to minimize the water. Therefore, I would need g prime set equal to 0, set equal to undefined. Well, this is a calculator problem. I'm just going to graph it, right? And then I'm going to do a sign chart for g prime from 0 to 18. There's going to be two zeros. One of them's at I can't remember it. 6.494, and the other one is at 12.975. Thank you. These are zeros. I believe this was a minimum, so it must have gone this way, I believe. So this is my sign chart for the derivative. That means when I'm looking at this guy, the graph goes down, over, up, over, down. I have two minimums. I have a minimum at 6.494, and I have a minimum at 18. So I would actually have to find g of, let's use a different color, g of 6.494, and I would need to find g of 18. How do I find both of them? Initial plus displacement, right here. So I would need to do that. Are there any questions on part C? All right. Part D. So after 18, you keep taking away water until it becomes empty. Let K be the time at which the tank becomes empty. Write but do not solve an equation involving an integral expression that can be used to find the value of K. So that one was pretty easy because you didn't have to actually do anything with it. So starting at time equal to 18, if I go all the way to time equal to k, then it has to be that it'll empty the tank. Well, here's how much water we had in the tank at 18. We found it in part C. Therefore, this equation would be integral has to give me 1310. That's how much displacement there should have been for the water to be completely gone. All right? Any questions on that guy? So it's a derivative / integral problem, but in context and not particle motion. Most of you guys can do context with particle motion. You start to have more trouble when it's not velocity and acceleration and position. Okay? The other question, this guy? So I think we've actually done this problem before. I think I've actually given you pieces of the problem before. So same thing as before, traveling with a velocity of this piece. What are they giving me there? At time equal to 0, the velocity is 55. That's some kind of initial. All right, and then other thing? Endpoints. So if they ask me for absolutes, I know I'm going to have to check the endpoints. So is the velocity of the car increasing or decreasing? Velocity would increase if A is positive. Well, this is the graph of A. Velocity is derivative, so this is really V prime is what I'm asking about. That's why I'm calling it A. When is the velocity? Let's see. Are we okay with B? Are we okay with B? Because I'm only going to go through the parts where we really need some help, and I want to focus on part C one more time. Question? On the time interval, from 0 to 18, other than time equal to 0, is the velocity. So at time equal to 0, we're 55. And then they want to know when velocity would be 55 again. So there's, let's call it velocity of something B. And you want this to be 55 one more time. Right? Okay. So I'm going to do it with a formula, and then I'm also going to say it in words. If I want to find an ending velocity, and they gave me this here, which is acceleration. Acceleration is V prime, right? Okay. So an ending velocity, I would need an initial plus a displacement. The initial was 55. Plus the integral from 0 to whatever that B value is of, oh sorry, I'm running out of room, A of t. Does that make sense so far? So does it make sense to you that if I have 55 plus a displacement, but I'm going to end up at 55, then the displacement has to be 0? What does displacement mean in the graph? It means that the net signed area has to be 0. So I would have to figure out how much this area is, and then try and see, can I match it up, and then cut off an area of that much continuously. Does that make sense? It's the first time, I think. There might be more than one. I can't remember. Okay? Let's see. Is the velocity. There might be more than one. I don't know if there is or not. But just one of them? Okay. All right. So I took what I knew. I knew the initial value. I knew how to find a velocity, and then I related it back to the graph. Tie head up. Part C, same as before, absolute minimum. I'm asking for, maximum. I want to maximize velocity. If I want to maximize a function, what function do I need to make the sign chart for? Travis, what sign chart should I make anytime I'm trying to find a max? Yep. Whose graph do I have? Do I have velocities? I have acceleration. So I actually have the graph sitting in front of me. So I would go 0 to 18. The graph has a 0 at 6. The graph has a 0 at 16. So if I'm looking at V prime, sign chart from V prime, I'm just looking at Y values. My Y values are positive, my Y values are negative, and then my Y values are positive. I'm looking for a maximum. I have one max here and one max here. So 6 and 18. And then how do we find ending values? V of 6 is equal to V of, I think the initial was at 0. From 0 to 6 of A of t. And then you would also do V of 18 is equal to, same thing. Initial plus displacement. Questions on that guy? At what time, at any point, is the velocity equal to 0? If you were able to do B, you should be able to reason through parts D. They're kind of similar, right? Okay? You guys are going to get slammed if you do not try these free response problems honestly. Because looking around, some of you are just, you have it blank. You write your A, you write part of a B, C, D, and it's just blank. But I need you guys to try them. You're going to get slammed. I'm going to, literally for the next few days, it's just a lot of AP practice. That's why the section's so long. We learned everything we need to learn. I could actually move on. Mr. Ish does 5.4 in one day. I'm doing 7 days because it's just AP practice after that. So you'll notice that a lot of your homework is just AP problems. The free response problems are going to be really important. It mixes all your topics together. All right, so with that being said, I do want to move into your notes. Before we start, your notes are actually just a problem to do. We're going to do it together. I would like for you to take out your notes, go to day 4, and on that page, could you please write for me, and I'm going to run out of space, so I'm going to move this up. I would like for you to write down, without looking, FTC1, FTC2, and you do not have to know which one's which. So if you know them but you don't know which ones they are, write them without a label, and then I'll tell you which one's which. So without looking, on day 4, at the bottom or on the top of that page, try and write your 2 FTC rules. One of them is old, the other one you learned last night. Gustavo, you okay over there? You and Ty are very out of it today. It is Friday. Highly doubt it's happening, but if there's no school on Monday, because magically snow really does come, your next homework assignment is just the next one, because we've learned everything at this point. If a blizzard comes, you just keep going in your homeworks day by day. Give you about 30 more seconds to just write down what you can. All right, so we actually learned the second one first. So if you want to know which one's which, the second one was the one that you learned how to evaluate a definite integral. F of B minus f of a. And I don't think anyone made the mistake in this class. It's this one, top one minus the bottom one. I think in the other class someone kept flipping them. FTC1 was the one you learned last night. I'm going to write it with the chain rule. So the rule says if you take the derivative of an integral from a constant value to a function of x, this x here and this x here have to be the same, then you can kind of look at it as if the derivative and the integral are almost canceling each other, but they don't exactly cancel each other. So when you do that, you place the u function into f, okay, multiply by the derivative of u. Okay? You guys came back pretty quick compared to, right? No, am I wrong? Oh. Wait, this is 5th. They kept you for 2 periods? Dang, that's ridiculous. Was it worth 2 periods? Oh. Good answer, James. Hi. I recorded for you guys just in case. Not the most magical thing, but I did. All right. So, here we go. This is the fundamental theorem of calculus. 2 is the one that you're just going to use. You're not going to even realize that that's actually a theorem. You're using it all the time. This one's a little bit trickier, but it's very obvious if they want you to use it. You have to see the derivative with the integral. They have to be there together. You can't just do magically things on your own. They have to be there together. And once you do that, you substitute your u function into all your x's, all of the x's that are in the function, and then multiply by the derivative. So that's the chain rule one. I'm going to keep writing it that way. Hopefully it'll force you to not forget about the chain rule. So, in the video at the end, I said that you might have a question for homework, and I think you ended up not having one for homework. That was a free response. This would be similar to a free response that you would get. Things I want to point out. I can tell that this is going to be an FTC1 problem because of the way that this function is set up from a constant to x. Okay, that's how I can kind of tell. Other things, that 0 is actually important. You have to know that they can change that to be another number. I can make it 5, and when all I'm asking you to do is take the derivative of it, it won't matter, but you'll see in this question that the 0 there will matter a bit. All right, so if you see a statement exactly like the one that's up here, and by exactly I mean a function is equal to the integral of. This equal is extremely important. As long as you have an equals, we can do things to the left and right side, and it won't change our equation. That's an important fact. So, when you see this, here's what you will do. You'll take the derivative of the left side, and you'll take the derivative of the right side of the equation. Because I took the derivative of both sides, we're fine. We're good. So, that then means, what's the derivative of h of x? H prime. The derivative of an integral from a constant to a function means I take this little guy, put it right in, and we get f of x times 1, but the 1 doesn't really do anything. But I'm still writing it so you understand I did my chain rule. All right, so we have a continuous function on an endpoint domain where y is equal to f of x. So this function, f of x, that's what it labeled the graph. Look at all your questions. H, 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 H. All your questions ask about h. They don't ask about f. So you're going to take your statement and change it. F of x is the same as h prime of x. So here's what just happened. I took a second semester question, and just by changing this statement, I've now made it into a first semester question. Because in first semester, I gave you the derivative graph, and I asked you a bunch of questions. Well, there you go. I just did it again a little bit differently. This is going to be a big key. You'll see a bunch of questions like this, all right? So let's go through. Let's try to get through each of them in 5 minutes. All right, part A, h of 0. Do you remember here it said h of x is equal to? Right? I'm going to erase the derivative marks just so that you see it clearly. So, because of that, h of 0 would be the integral from 0 to 0, which is how much? 0. So I'm going to just finish it my statement here. Equals 0. So part A is 0. I know that. How do I know that? Because the integral from 0 to 0 is 0. The integral from 5 to 5 is? Integral from pi to pi, e to e, always 0, okay? So it doesn't matter what it is. All right, next question. On what interval is h increasing? Well, what's the definition of h increasing? The derivative is greater than 0, positive, perfect. So I just need the derivative sign chart from 0 to, I think, 12. I have h prime, but I want h prime sign chart. What am I looking at? Y value. So my y value is 0 at 6. My y values are positive. My y values are negative. Therefore, it's increasing from 0 until 6, and I gave my reason already. Here's part B. We're going to have to go in like a weird little order so that I can fit things. All right. Part C. When is it concave up or concave down? So part C, concavity would be h double prime. Concave up would be greater than. So now I need h double prime's sign chart from 0 to 12. That's my slopes, right? Some people will argue it. I'm pretty sure there's a horizontal tangent right there. So I'll put a 0 there. Where's my other one? Yeah, I would say 9. It's a little bit off. I'm sorry about that. I would say 9. On the AP test, they're very clear. They will tell you where the horizontal tangents are. All right, so slope is negative, then slope is positive. Therefore, I am concave up from 9 to 12. Okay, that one's good. All right, so is h of 12 positive or negative? So h of 12, using the definition, would be from 0 to 12 of f of t dt. Some people will argue, but this one says f of x, and this says f of t. Integrals, that variable doesn't matter. Derivatives, it matters a lot. Okay? It's a very odd thing. It's called a dummy variable. I could explain it, but I'll just confuse you guys more. Just note, integrals, the variable of integration won't matter. It won't matter as much.
Teachers and students, pardon this interruption. I wanted to let you know that we are going to have a homework period right after the next bell. At that homeroom, you will pick up course registration cards, the official course registration cards for next year. So do not go to the cafeteria. Report to your homerooms when the bell rings. Thank you.
So, net signed area. Looking at the purple, net signed area, positive or negative? Positive, because it's more on top. Maximum is actually the easy question, because you can see the maximum. It's at h of 6. Okay? Minimum is a little bit harder. Minimum, if you look at my sign chart, I went up, flat, down. So where are my possible minimums? At 0 and at 12. So I have to compare the values. Problem set up nicely. What was h of 0? What was h of 12? Something positive. That's all you care about. Which one's going to be the minimum then? H of 0. Okay? So, kind of combining everything together. You can see that. We're doing stuff from derivatives, integrals, second derivatives, all your definitions all mashed into one. Real quickly, if you are an underclassman, if you make it through this course, you will most probably take BC Calculus. If you are a sophomore, you are definitely either retaking this course or taking BC Calculus. If you are a junior and you absolutely despise calculus after this class, and you know you are not going to be in sciences, business, engineering, computer science, any of that stuff, you are permitted to consider AP Stat, but I would stay away from that class if you are going to do any type of technical field. Okay, so if you are confused on what to register for next year, please see me. IB students, if you've taken this class, most of you will probably want to take IB Math SL, but IB Math Studies is an option. But come and see me if you have questions about that.